Section 5.4 is greatest common factor and factor by grouping. Number one, we're going to factor out the greatest common factor, and we're going to turn to the next page so that we have some more room to work on that. So here's our original problem. We take our coefficients, 42, 12, and 24, and we're going to factor using a factor tree, which is 6 times 7. 6 is 2 times 3. I'm going to circle them when they're prime. So I'm going to come down here and I'm going to say that's 2 times 3 times 7. Now I need 3 A's. 1, 2, 3 A's and 1 B to represent this term. We're going to do factor tree for 12, which is 4 times 3, and 4 is 2 times 2. So I have 2 times 2 times 3. I need 2 A's and 2 B's for this term to be factored. Next I'm going to do 24, which is 6 times 4, 2 times 3. 4 is 2 times 2. So if I put those in order, I have 2 times 2 times 2 times 3. 1A, 1, 2, 3 B's. And then next, greatest common factor says what do they all have in common? They have 2, they all have a 3, they all have an A, and they all have 1 B. So my GCF, my greatest common factor, is going to be 2 times 3 times A times B. So I'm going to use a 2, a 3, an A, and a B, and I multiply that out. My GCF is going to be 6AB. So we said this came out to be 6AB is my GCF of number 1. Number 2, we're going to see that they both have, each terms both have a 3 in them. So if I factor out a 3, I'm left with, if I take a 3 out of this, I have X. And if I factor out a 3, divide 9 by 3, I have a 3 left over. And there's nothing else I can do. Number 3, these both have a 2 and an X. They have a 2 and an X in them. Their common factor is a 2 and an X. If I divide a 2 and 1X out of this, I have 1X left over. Minus, if I divide this by 2, 4 divided by 2 is 2. And I take an X out of it, I just have that. Number 4, these both have a negative, they both have a 3, and they both have an X. So the negative 3X is the GCF. If I take a negative 3 and one of the X's out, I have 1X left over. If I divide this by negative 3, I get a positive 2, and when I take the X out, it's gone. Number 5, they both have a negative 5x squared. They both have a negative 5 and they both have at least 2 x's in them. So take my GCF out, divide this by negative 5x squared, and I'm going to get 2. If I take 2 x's out of this, I have 1 left over. Negative 15 divided by negative 5 is a positive 3, and the x squares cancel each other. So I have that. I'm going to come over here and I'm just going to skip down to number 8, and I say that these two are exactly the same. So when I take the fact, that's one of the factors, and what's left over on the outside becomes the other factor. So that becomes 2x minus 3. So when we look at that on number 9, I'm going to say when these parentheses match up, that means it's one of the factors. And what's left over outside the parenthesis becomes the other factor, 5x plus 3. And so we see that also in number 10. When these match up, it's one of my factors. What's left over on the outside is a 3x. There's a known negative 1 there, so that's going to be 3x minus 1. That's for factoring. Our next thing, we're going to factor by group, and when there are 4 or more terms, we want to group these first 2 and group the second 2. Take a GCF out of this first pair. They both have an A in them, So if I factor out an A, I have a B left, and if I take an A out of this, I have a 10. In this red one, these both have at least a 2 in them, so if I factor out a 2, factor out a positive 2, then I have B plus 20 divided by 2 is 10. Now I notice that just like previous, when these match up, that becomes one of my factors. And what's left over on the outside becomes my other factor, so it's A plus 2. So factor by grouping is that process. Number 2, so I'm going to group the first two, group the second two, and okay, in blue, these both have a 4 and they both have an n. So if I factor out a 4n, I would say 8 divided by 4 is 2, and if I take n, I'm left with m. 28 divided by 4 is 7, and if the n's cancel each other out. So in red, they both have a negative 5. If I divide this by negative 5, I have a 2m left, and if I divide this by negative 5, I have a 7. Once again, we notice that when these match up, it's one of our factors, 2m plus 7, and what's left over on the outside is our other factor, which is 4n minus 5. Our last one, we're going to group these first two and group the second. Nope, we see that 3r minus 4 doesn't have anything in common, so we're probably going to have to rewrite this to group it. So we're going to pause for a minute and see what we need to do. So I'm going to rearrange the order of this to 2qr minus 3r minus 16q plus 4, so that now I can group these first two and they have a common factor, and then these. So the first one in blue has a common factor of a 3, and they both have an r. So I have 4q left minus, and I have to put 1 as a placeholder. So then now these both have a 4. Let's do a negative 4 so that this becomes positive. So we're going to take a negative 4 out of both of them. When you divide this by negative 4, you get a positive 4q, and you get a negative 1. Now when these match up, we have 4q minus 1, and we have what's left on the outside, which is 3r minus 4. So sometimes when we factor by grouping, we may have to rearrange the order of the terms so that way there's common factors in each set to be factored out.